So this is a good question from number systems. So basically, you have M4 as 9n square plus 72. Just turn the suggestions off. M to the power 4 minus 72 is 9n square. Or what it means is that because n square is an integer and m is also an integer, so m to the power 4 is congruent to 72 mod 9, which is basically what it basically means is that m to the power 4 minus 72 should be divisible by 9, and or m to the power 4 is congruent to 0 mod 9. Now the reason being that 72 is divisible by 9. So m to the power 4 should be divisible by 9. Right. So m to the power 4 is some k into 9. Now because m to the power 4 is essentially m square to the square, thus k is definitely some square of a number, some square of some, say, alpha square into 9 into 3 square. Thus m square is congruent to 0 mod 3, or m square is divisible by 3, and the only way that is possible is when m is divisible by 3. Or maybe we can stop at that, but anyways, m square, it's, let's say, suppose is 3k. Let's not dive deeper. Thus 9k to the power 9k square is m to the power 4. Thus 9k square minus 72 is 9n square. Or k square minus 8 is n square. Now see the curve for x square. The gaps between consecutive numbers for x is equal to 1, x is equal to 2, the gap is 1. But when we have 3, then the gap increases. Then, sorry, this is not the gap. So basically this is the gap. But when you have 3, you can clearly see that the gap increases manifold. So it keeps on increasing. Right. So for k is equal to, let's say, plus minus 1. Plus minus 1, you have n square is minus 7, which is not possible. So n has to be greater than 3. Okay, 3 for to have some 2. Obviously n square is greater than equal to 0, and k square should be greater than 8, and which only happens when k is, let's say, again plus minus 3. So for plus minus 3, we have n is equal to plus minus 1. Right. For k is equal to plus minus 4, you have 16 minus 8, n square is root 8, which does not work, so not possible. K is equal to plus minus 25, then n square becomes 23. Sorry, n square becomes 25 minus 8, which is 17, and 17, which is again not a permissible value. Thus what it means is, and why should not we bother finding more values of k is because the distance between two consecutive squares is increasing. Basically, k square minus n square is the distance between two consecutive squares, and it's constantly increasing as you increase the value of k. So this is the only solution. Thus all the pairs work. So plus 3 plus 1 plus 3 minus 1 minus 3 plus 1 and minus 3 minus 1. So there are 4 potential solutions. A possible mistake that I made while solving the question was that m to the power 4 minus 9n square, I took it as 72, and m square minus 3n m square plus 3n should be equal to 72, and then I try to find all the factors of 72, 172, then 236. So you essentially have 12 factors. So 3, 24, 4, 18, and I think 6, 12, 9, 8. So for only this value you get a, or yeah, I think for only this value we get a solution for m square and n, but this would have been the case when m comma n would have been strictly greater than 0, and clearly from the above case you have only one solution in that for that. But when negative integers are allowed, as the question explicitly says that m and n are integers, then we consider all of them.